My student physics class and chapter number 5. The name of the chapter is here, state of matter and pressure. My today's topic is, I'm going to solve some creative question in my today's class about Archimedes' law. At first, my dear student, I'm going to solve the board question, that is all board 18. So this is all board 18. Okay, this is a very important question, my dear student. The area and height of a rectangular object. The area and height of a rectangular object are 24 centimeters square and 3 centimeter respectively. The weight of the object in air is 1.4 Newton. The weight of the object is 1.4 Newton when it is immersed in kerosene. When it is immersed in kerosene. Okay. Kerosene. The density of the kerosene is 800 kg per meter cube. The density of the kerosene is 800 kg per meter cube. Question number C. Determine the density of the object. Determine the density of the object. And then question number D. Analyze mathematically whether the given information follows Archimedes' principle. Analyze mathematically whether the given information follows Archimedes' principle or Archimedes' principle. Explain mathematically. Explain mathematically. Okay. My dear student, you see that the area and height of a rectangular object are respectively 24 centimeters square and 3 centimeters. The weight of the object is 1.4 Newton when it is immersed in kerosene. The density of the kerosene is here 800 kg per meter cube. And then it is said to me that determine the density of the object. And question number D, Analyze mathematically whether the given information follows Archimedes' principle and explain mathematically. Now, my student, I'm going to solve question number C. In my last class, I already solved a creative question on the basis of this type, Archimedes' law. Now, give me some idea. How can I find out the density of the object? My student, give me some idea. How can I find out the density of the object? Any one of you, my student, give me the idea.
So rho is equal to m by v.
Density rho equal to is the ratio of mass per unit volume. Very good. Rho equal to is the ratio of mass per unit volume. But you see that, how can you find out volume of this body? My student, from the given information, how can you find out the volume of this body?
Product of height and area.
Exactly. So volume of the body V will equal to what? Is the product of height and area. This is height and area means A into H. Okay. 24 centimeters square. You need to convert this in terms of meters square, dividing it by 1,100 square. And then height H equal to 3 centimeter divided by 100 meter will equal to something meter cube. Now find out please what is the volume of this body. My dear student, now find out what is the volume of this body. Find out please. Yes, volume becomes, my dear student, volume becomes
So 1.2 into 10 to the power minus 4.
1.2 into
10 to the power minus 4.
Very good. Now, the next step, I'm going to find out the value of mass of the body. Give me the idea, my dear student. How can I find out the mass of the body? My dear student, give me the idea. How can I find out the mass of the body? What is the mass of the body, my dear student?
So weight of the object in kerosene.
Okay, very good. Weight of the object in kerosene. And then?
Divided by gravitational acceleration.
Okay.
Gravitational acceleration.
Okay, my dear student, you see that volume V is correct, but I'm going to find out the mass of the body, okay? So mass depends on which weight, weight in kerosene or weight in air. By the student,
Weight in air.
mass depends on weight in air. Very good. So how can I find out the weight in air from the given information? By the student, any one of you, give me the idea. How can I find out the weight in air? Because you see that in the stem, it said to me that weight of the object is 1.4 Newton when it is immersed in kerosene. So when it's immersed in kerosene, then its weight is 1.4 Newton. Okay, then its weight is 1.4 Newton. Okay, now I'm going to find out its mass from the weight in air, not in kerosene. So how can I find out this?
So 1.4 Newton is main weight minus the upthrust.
Upward thrust. Okay, you can say this
Yes.
information from which formula? Yes, my dear student. You can say this information from which formula? From the formula of Archimedes' law. Very good. That's why, suppose this is equation number 1. So there is no other way without Archimedes law to find out the weight of the body in air. That's why now I'm going to find out Archimedes law to find out the mass of the body. Okay. According to Archimedes law, I can say that weight in air minus weight in liquid, and from now this is kerosene, will equal to upward thrust. And you know that, my dear student, this upward thrust is nothing but the buoyancy. This upward thrust is nothing but the buoyancy. Okay. So weight in air will equal to what? Weight in kerosene plus this is upward thrust. And from weight in air, you can say that it will equal to mg, which is weight in kerosene 1.4 plus upward thrust is nothing but V, density for kerosene, and then G. You know that upward thrust or buoyancy is related to which function? This is related to the density of the liquid. And in this case, the density of the liquid is nothing but kerosene. So we can say that upward thrust will equal to V rho G. V is the volume, rho is the density, and G equal to 9.8. So mass of the body M will equal to what? 1.4 plus V, density for kerosene, into G and divided by G. Now put down the values. 1.4 plus volume V equal to 1.2 into 10 to the power minus 4. Density rho for kerosene equal to 800 and G equal to 9.8 and divided by 9.8. So what is the mass of the body? Find out this. Right, a student? From this given information, find out this. What is the mass of the body?
So 0.23 kg.
So mass of the body will equal to 0.23 kg. Very good. Now, by using the mass and by using the volume, you can find out very easily now the density of the body. So the density of the body rho, it will equal to mass of the body divided by volume of the body. Mass of the body is 0.23 kg, and then volume of the body is 1.2 into 10 to the power minus 4 meter cube. Now find out the density of the body in terms of kg per meter cube by the student. Now find out density of the body in terms of kg per meter cube. Okay.
So 1.9 into 10 to the power 5 minus 5.
I think please recheck your calculation.
Yes, sir.
Sir, 1916.67.
19 by the student.
16.67.
Okay.
16.
Also, please recheck the calculation by the student. Please recheck the calculation here.
স্যার ভলিউমের অ্যান্সারটা রং হয়েছে।
Okay.
স্যার ভলিউম 0.2 into 10 inverse 5 হবে না?
Okay, no problem, no problem. Okay. So what is the volume? What's the correct answer for volume by the student?
7.2 into 10 inverse 5.
7.2 into 10 inverse 5. Okay, very
5.
good. And now Please recheck the value of mass by the student. Please recheck the value of mass here.
স্যার ম্যাথেরটা ঠিক আছে।
So mass is correct. Okay. Now find out the correct density of the body. What's the correct density of the body? Okay. Now find out this, my dear students. So this is 7.2 into 10 to the power minus 5. Okay. So by using this value, please find out the correct density of the body.
স্যার
Sir,
3.194 into 10
sir.
to the power minus 7.
Yes, yes.
And sir, answer of mass is 0.20 kg.
0.20 kg. Okay. Okay, please,
Yes,
please please recheck your calculation to find out the mass of the body. Okay. I repeat it again, my dear student. Please recheck again about the mass of the body. Okay. All of you take calculator, my dear student. All of you take calculator and recheck the result that is given at the mass part. And make sure that your answer is correct, my dear student. And make sure that your answer is correct. So now what is the value of mass? What is the correct value of mass, my dear student?
0.20.
Okay, so this is 0.20. No problem. Okay, this is 0.20. Now find out the correct density of the body. My dear student, now find out the correct density of the body.
So 2777.78 kg meter per kg.
2777.78 kg per meter cube. Okay, is it
Yes.
correct, my dear student? Now it is correct.
Sir, yes, sir.
All of you, now it is correct. Please recheck it. Okay, and I think this one is correct answer. I think so, but make sure that it is correct answer. All of you take calculator and recheck this calculation. Okay, and recheck this calculation. Have any confusion, my dear student? Anyone
Sir,
of
it
you?
is correct.
Very good. Have you any confusion from this question number C, my dear student? Any confusion here?
No, sir.
Any one of you? Any confusion?
No, sir.
Okay, very good. So if you have no confusion, then I'm going to solve question number D. It is said to mean question number D that, my dear student, it is said to mean question number D that analyze mathematically whether the given information follows Archimedes principle. Okay, does it support or not? Let's say this. Can I erase, my dear student? Can I erase left side of the board? My dear student, can I erase the left side of the board?
Yes, sir.
Okay. Now, question number D. You know that according to Archimedes' law, you can say that weight in air, simply this is weight in air minus this is weight in kerosene will equal to upward thrust. Okay, my dear student, will you call the upward thrust or buoyancy? I'm going to justify that this equation number 1, it can support Archimedes' law or not. That's I'm going to put down the values in the left side. So from left side, my dear student, from left side, we can say that weight in air minus weight in kerosene. Okay, so weight in air equal to what? Weight in air equal to here m into g, and minus weight in kerosene equal to 1.4. What was the mass of the body from question number C? I think it was 0.2.
So 0.20.
Okay, very good. So it was 0.20 and G equal to 9.8 and then 1.4. So it is something Newton. Is the difference of weight, is the lost weight that you find out mechanically from this given data.
0.56.
So 0.56.
So it is 0.56. Okay, 0.56. Now, my student from right side. Okay, upward thrust. You know that upward thrust is given by the liquid like kerosene. I repeat, my student, upward thrust is given by the liquid like kerosene. Okay, so here kerosene can apply the upward thrust. So this upward thrust will be equal to V, density for kerosene, and then G. And V equal to what? V equal to, what was the value of V from question C, my dear student? What was the volume V?
7.2.
7.2 into 10 to the power minus 5.
2 into 10 to the power minus 5. And then density rho for kerosene equal to 800 and G equal to 9.8. So this is the upward thrust that is given by the liquid kerosene. Now find out the value of upward thrust here.
So 0.56448.
So upward thrust equal to 0.56448.
448.
Okay, so 0.56 is enough, my dear student, because this is just equal to the value of left side. Okay, so you can say that in this case, the weight lost by the body will equal to what? Will equal to upward thrust or weight of the displaced liquid. And this is the basic principle of Archimedes' law. So we can say that this given data, this given information can support Archimedes' law. Okay, my dear student, this given information can support which law? It can support Archimedes' law. Because in this case, we see that weight lost equal to 0.56 Newton and weight of the displaced liquid is equivalent to upward thrust equal to 0.56 Newton. So STEM can support Archimedes' law properly. Any confusion, my dear student, from question number C or question number D? My dear student?
No.
Any confusion of you? Any one of you, my dear student? Any confusion here? Okay. Now I'm going to solve another question, my dear student. I'm going to solve another question, okay? So let's solve another question, my dear student. Next question, my dear student. This is a question for Select Board 19. So this is Select Board 19, my dear student. There's a rectangular shaped body, my dear student. Here, there's a rectangular shaped body. A body, this body is named a body. Having density rho will equal to 1.04 gram per centimeter cube. Mass of the body is 500 gram. 500 gram. Length of the body is 10 centimeter. And breadth of the body is 6 centimeter. And breadth of the body is 6 centimeter. Density of water equal to 1000 kg per meter cube. And density for glycerin equal to 1260 and 60 kg per meter cube. Okay, this is the density for glycerin. Question number C, my dear student, determine the applied pressure by the liquid on the body A, mentioned in the stem. determine the applied pressure determine the applied pressure by the liquid on
So 6 centimeter to key.
is the breadth of this box on the A body, mentioned in the stem. Number D, will it be equal buoyancy? Will it be equal buoyancy when the body put into water and glycerin? When the body put into water and glycerin. Explain mathematically or analyze mathematically. Okay, 6 minutes are left. Final student. You see that there's a rectangular shaped body in front of me. The body having density rho equal to 1.04 gram per centimeter cube. This body having mass 500 gram, length 10 centimeter, breadth 6 centimeter. I repeat, my student, length 10 centimeter and breadth 6 centimeter. And then density of water is 1000 kg per meter cube. Density of glycerin is 1260 kg per meter cube. In question number C, it said to me that determine the applied pressure by the liquid on the A body. And question number D, will it be equal buoyancy when the body put into water on glycerin? My student, when the body put into water and glycerin, okay? Please mute your microphone, my student. Please mute your microphone. Okay. Now, question number C. I'm going to find out the applied pressure by the liquid. Now, give me the idea, my student. How can I find out the applied pressure by the liquid on the body A? How can I find out this, my student? Any idea? You see that mass of the body is given, and here length is given, breadth is given. Okay, of the body, length is given, breadth is given. Okay, so by using this information, my student, how can I find out the pressure?
So pressure is equal to F by A.
Exactly, very good. So in this case, pressure P equal to what? Pressure P equal to force per unit area. Now, force is nothing but the weight of the body. In this particular case, my student, force is nothing but weight of the body. So force F equal to, the value is mg and divided by A. So here, mass equal to 500 gram, 0.5 kg, and G equal to 9.8, and area A equal to what? This is the product of length into breadth. Length is 10 centimeter and breadth is 6 centimeter. So length is 10 centimeter divided by 100. And you see that breadth is 6 centimeter divided by 100. Okay. So pressure P equal to something Pascal. Find out this by the student. What's the pressure in this case? My student, now find out this. What's the pressure in this case? Okay. What's the value of pressure?
816.67.
816.67 Pascal. Very good. Now question number D. It is said to me that will it be equal buoyancy for these two cases? So at first I'm going to find out the buoyancy in the case of liquid, water. So first of all, buoyancy for the case of water, my dear student. Now let's see what is the buoyancy for the case of water. Okay, buoyancy for the case of water. You know that, my dear student, buoyancy will equal to what? Will equal to V, rho, and then G. And rho for water. Now give me the idea. How can I find out the volume V of the body? My dear student, how can I find out volume V of the body? With the help of density of the body. You know that density of the body is given rho equal to, this is mass per unit volume. So volume equal to what? Mass divided by density. So mass equal to, you see, 500 gram, 0.5 kg. And the density rho will equal to 1.04 gram per cc. When you multiply it by 1000, it can convert into kg per meter cube. So it will equal to what? It will equal to here 1040 kg per meter cube. How can I convert this? Multiply this function by 1000. Okay. So whole divided by 1000 will give you the value of volume V. So it will equal to 0.5 into 10 to the power minus 3 kg per meter cube, my dear student. Kg per meter cube. Okay. So here volume V equal to 0.5 into 10 to the power minus 3. And density rho equal to 1000 and G equal to 9.8. So find out the upward thrust or buoyancy that is applied by the water on the body. Make it hurry, my dear student. Make it hurry. Okay, and similarly, you can find out the buoyancy for the case of kerosene, for the case of glycerine. Okay,
4.9.
it will equal to what, my dear student?
So 4.9.
It is 4.9. Very good. Similarly, you can find out the buoyancy or upward thrust that's applied by the glycerine. Okay, and this part is your homework, my dear student. This part is your homework. Okay, you can solve this question, this part of question at your home. So that's all about my today's lecture. So bhalo thakba. See you in my next class. Okay, my dear student. See you in my next class. Okay.